This is the Westell presentation on our new ProtectLink version 2 fiber DAS system, which is comprised of a unit called the HE, the head end, and the RE, the remote end. And we're going to see how it works today with our recently introduced 2.5 watt version of our CS45 700 800 BDA. So let's begin. My name is Tom Warfield. I'm the in-building wireless training manager, and joining me today is Bob Joslin, Vice President of in-building wireless sales. Bob, you want to introduce yourself?
Yeah, thanks, Tom. Good afternoon, everybody. We're excited to share with you this new product release from Westell. I'll be here with Tom and monitoring the Q&A as we go through this. Thank you for joining.
Yeah, thanks, Bob. So yeah, I'll be doing the presentation. Bob will be monitoring the Q&A in the background. A couple of things to go over first is here's our regional sales map, which is changed since maybe the last time you saw it, if you've ever seen it before. We have Bill Dow in the northeast, which is the light blue area, which has changed a couple of states recently. And in the southeast, we have Dave Merkel. He's in the yellow. And then we had a huge west region, which we've just recently divided in half. We have a new area. This is in the green. And right now, Bob is handling any questions with that area. But we hope to announce a new sales guy next week. So stay tuned for that. And then in the brownish tan area, the West Coast, we're currently interviewing for sales reps there. If you know anyone or are interested, let Bob know. We'll be hiring. So we hope to fill that fairly soon. So stay tuned. If you're in the green or the brown area, stay tuned to who your new sales manager is very soon. Most of our Westell BDAs are sold through distributors. Here are the distributors that we work with. And in case you're new to Westell, don't worry about writing all this down. After the webinar, we will provide a recording of the video plus a PDF of this PowerPoint that I'm going over. So anything you see, don't worry about as far as taking notes. You will get the presentation after the meeting is over. So today's agenda is before we get to the fiber DAS products, we're just going to review the new CS45 2.5 watt BDA. We introduced this earlier this year. We've been selling this for a couple of months now, but let's just go over that again just to make sure everybody understands a product that this fiber DAS system is going to work with. So we'll go over its dimensions and weights, its mechanical layout, electrical specifications, RF specifications, and then its associated battery backup unit. And just a quick couple of screenshots of the graphical user interface. And then finally, we will get into the new ProtectLink version 2, Fiber DAS, HE, and RE. And why would you want to use that instead of BDAs or multiple BDAs? And we'll review the part number and kits that we have with that. And then if you have any questions, we'll answer those all at the end. So let's get going with the new CS45 2.5 watt VDA. And that's its part number now. And again, like I mentioned, it's been available for a few months now. This is it. You may have seen our CS45 half watt BDA before. It's probably the smallest and lightest half watt 700 800 BDA on the market, and this new 2.5 watt is just slightly bigger, but it's still very compact. There's the dimensions right there that you can see, and coming in about 26 pounds. It's probably half as much weight as a lot of the other 700 800 BDAs out there. Mechanically speaking, it's NEMA 4 IP65. All the conduit fittings are on the bottom. And on the top, we have two female RF ports for the donor and service antennas. Down below, we have an RJ45 commissioning port and compression screws inside for the alarming. It's wall mountable, it's lockable, and it has a built-in annunciator that you can see there on the front panel, which includes an oscillation LED, which makes it IFC 510 compliant. If we open up the lid, this is what you'll see inside. Over here, starting on the right, we have a module on the lid itself, and that's the alarm annunciator and the required buzzer for compliance with the codes. And it's a very integrated design. You don't really see a lot of modules. Over here on the left-hand side, we have basically only 3 modules. We have what I call the interface module. Any connections to the outside world will get connected through here, including the fire alarm control panel, monitor modules. The battery backup unit will get connected there. The emergency transmit disable, some might know that as an EPO switch, gets connected there. And then all the web and local interfaces would get connected there as well. Down here in the lower left-hand corner, we have this module here with 3 switches on it. This black button right here is just the on-off switch, or excuse me, this black button right here is just the on-off switch for DC on and off. This button right here detects whether the lid is open or closed. And the red button is a multi-function button, which can either mute the alarms, reset the unit, or do a factory reset. And then what's most different about this 2.5 watt version compared to the 0.5 watt version is these connectors right here. These are 2 SMA RF connectors, which will send downlink and uplink signals to and from the new fiber DAS system. Just like the 0.5 watt version, this thing operates off of 12 volts DC. Most BDAs are 24 volts, but this one's only 12. It consumes under full power about 123 watts. And there's its operating temperature. It is 700, 800 dual band. There's the downlink frequency ranges and the uplink frequency ranges. And if you're paying attention to the 700 side, you'll see that it does not pass band 14. So the duplexer does its best to block band 14 FirstNet. The donor and service ports, we measure VISWAR/return loss, which are seen in the GUI. And output power per band for downlink is 2.5 watts, which is equivalent to 34 dBm. And that's adjustable in 1 dB steps over a 30 dB range from 4 dBm up to 34. And for uplink, 27 dBm or a 0.5 watt. And once again, a 30 dB range from -3 dBm to 27 dBm, and again in 1 dB steps. Downlink gain is 90 dB. Again, a 30 dB range from 60 to 90. And for uplink, we offer 80 dB of gain. And once again, another 30 dB for 50 to 80 dB in 1 dB steps. One of the great things about this 2.5 watt BDA is we have 96 filter pairs, of which is assignable in groups of 8 per band. So it's not like we take the 96 and divide it half for 700 and half for 800. You can say, I want up to 80 filters in 1 band, which would leave 16 for the other band, or in any kind of groups of 8. So, for example, you can have 33 to 40 filters in 1 band, which leaves up to 56 in the remaining one, or any combination that you see right here in this table. Filter characteristics. The unit comes Class A, Class B, or complete wideband, which is all programmable in the graphical user interface. And if you select the Class A mode, you have 12.5 kilohertz, 50 kilohertz, and 75 kilohertz per passband. The Class B mode is just a single option, 150 kilohertz. And then we have wideband mode, which we pretty much bypass the digital signal processing filters and just depend on the duplexer's filtering. So the entire 700 or the entire 800 band is passed. Some of the features is we have fast AGC or N squelch, which is phase 2 P25 compliant. So it's very important. We have 2 time slots with P25 phase 2, and we want to be able to switch between time slot 1 and time slot 2 if they come in at different power levels. This unit does that. It has a dynamic range of 6 dB for the automatic gain control. And this unit also has a feature, along with our half-watt version, of automatic uplink amplifier shutoff. So when this amplifier shuts off, there is 0 uplink noise being transmitted across the jurisdiction. And this kind of happens automatically. So after 1 hour of no uplink signals breaking squelch, that uplink amplifier will turn off. And then as soon as uplink breaks squelch, it turns instantly back on. And for you in the Seattle area, this is a requirement for PCERN, so it is PCERN compliant. And of course, we have uplink squelch. And that's adjustable between minus 100 dBm up to minus 70. This unit also features dynamic AGC on the uplink, which you can turn on or off. And what that does is it's how do you allocate all the 27 dBm of power for uplink? You have 2 choices. With the dynamic AGC on, what it does is it dynamically changes the uplink power amp power depending on how many channels are actually breaking squelch. So I don't care how many channels or filters you have programmed into the BDA. If only one filter has its squelch being broken, it can get full power. And if 2 signals break squelch, then they're each going to share the total power, each get a half, and then 3 will be a third, and 4 will be a fourth, and so on. But if you have 4 channels programmed and you turn AGC off, then they automatically power share equally. So we allow you to choose what you want. With dynamic AGC off, it's very consistent. It's very easy to do a link budget. With dynamic AGC on, the power is constantly changing depending on how many signals are breaking squelch. But if you need absolutely the most power for uplink to reach the tower, that might be the better option. If you needed a remote annunciator, we do have that. It gets connected through RS485, RJ45 ports. There's its part number. So it connects through Cat5, Cat6, and you can have up to 3,000 feet between it and the CS45. When it comes to commissioning this BDA, there is no separate application. You just log in with a internet browser, your choice, Chrome, Edge, Internet Explorer, Safari, whatever you want, and you're off. So just connect the Cat5, Cat6 cable to the GUI port on the bottom. It's dynamic IP addressing, so you don't need to go in and configure static IP. And if you had to, you could even hook up your smartphone. I've done it with iPhones and Android phones, and just hook a USB-C to Ethernet adapter to that phone. And for at least Android, turn off the Wi-Fi, turn off the Wi-Fi, and you're good to go. You can commission this thing on your smartphone. And this is one of the really good things about this Westell interface is it's super easy. This would be the main screen that you would see. It's very simple to navigate. So this is the main screen. This is the alarm page. I'm sure that if you're new to BDAs, just a quick glance here, you could see which alarms are active and which ones need attention. And this is the RF configuration page. Very easy to navigate and understand how to set anything up. The battery backup unit for the CS45, that's its model number right there. We have lots of, maybe 3 battery backup units for Westell, and this is the one for this unit and for this unit only. This BBU does not work with any other of our Westell BDAs. So the battery charger is in the battery backup unit, and the alarms that you would associate with the battery backup unit are generated in the battery backup unit. So in order for the enunciator of the CS45 BDA to enunciate it, we'll need to send all those alarms along with the DC power from the battery backup unit into the BDA. It's 12 volts, as we mentioned earlier, and the BBU can have 1 or 2 batteries. So we only have 1 battery part number, and that's what you see there. You install one of those into the battery backup unit and it will last for 12 hours. If you install 2 of those exact same part numbers, then and wire them in parallel so you still get the 12 volts, then it's good for 24 hours. And here's again just some images of and dimensions of the battery backup unit. And again, don't worry about trying to memorize this. You'll get the PDF later on. And the BBU comes with a wiring harness with these 2 connectors already pre-terminated. So there's one connector for the 12 volts, and there's one other connector for the battery alarms. So you just send that through a conduit port from one to the other and click them in, and you're done. There's no wiring or I should say screwdriver adjustments here. It's all just click on. All right, so that's an overview of the CS45 2.5 watts. So now let's take a look at optical fiber. And we've had a ProtectLink fiber DAS product. We never called it version 1 because it was the only one, but now that we have a second one, now we're going to call that first one version 1, and this one now is version 2. And this works with the CS45 that I just described. And it also works with several of our UHF and VHF BDAs. Our UHF and VH BDAs, we have high power to mid power. There's certain model numbers with the mid power BDAs this will work with as well. So exact same part numbers, exact same connections, just with UHF and VHF instead. So why would you want a fiber DAS system rather than maybe multiple BDAs? There's 2 scenarios where we want that. Large buildings is one of them. Every BDA has a certain amount of downlink output power, and you can connect a certain amount of antennas to that. And if you try to hook more antennas up, you just get too little power to each antenna and you don't get the coverage that you want. So you have a choice of adding a second or a third or a fourth BDA, but we say that's really not a good idea if it's the same venue. A better idea is the fiber DAS system. And we'll explain why that is here in a minute. So this is one scenario. And the other scenario where you'll see a fiber DAS system is you have a campus setting and every one of these buildings. So right here we have 1, 2, 3, 4 buildings. And let's say every one of them fails the grid test and every one of them needs enhanced coverage. Do you put in 4 separate BDAs or you put in 1 fiber DAS system? We say put in 1 fiber DAS system. And why is that? Why don't you want to put in multiple BDAs? Is every time you have BDAs close to one another, they have an opportunity to interact with each other, which can lead to oscillations, timing issues, and increased uplink noise. And a fiber DAS system takes care of all of this. So here are our new fiber DAS components. We have the HE unit, this one on the left, and HE stands for Headend. So this will get mounted right next to the master BDA. And I'm showing it with the front panel off, but if the front panel were on, you would see that it does have an alarm annunciator on it, along with the fiber ports, whether they're green or red. And over here on the RE side, which is the remote end, we'll have another unit, and that will get mounted on the same board as the remote BDA. And again, this also has a remote annunciator on it. In between the HE and the RE, you're going to wire fiber, and the fiber is going to be the specifications, going to be single mode. The connector is SC-APC, so this is a SC-APC connector. The green represents the APC, the angled physical connector. And this rectangle connector right here that we see, that is the SC part. Single mode is generally yellow cable, so what you're going to see is yellow cable with a green rectangular connector on the end. If you're using this, you're using the right one. As far as specification of this cable, we have a 5 dB of optical link budget, so don't lose any more than 5 dB of optical power from one end to the other. And we have a reflectivity spec, similar to Viswar return loss. Whatever gets reflected back to the transmitter better be 60 dB or less fiber optic power. And you measure that with an OTDR, optical time domain reflectometer. And it's important that if you use a patch panel, it also must be APC. So this is an analog system, and it does not like to see reflected power. So we want to avoid flat connectors. So that's why we use angled. And if you use a patch panel, it also needs to be angled as well. So this is how everything gets connected. So here we see the CS45 and its associated battery backup unit like I described earlier. And we're going to connect 3 sets of connections to this CS45. The CS45 has an RJ45 port, so we're going to connect a Cat5, Cat6 cable to that, and that's going to be to send data throughout the system. Then we're going to have 2 SMA jumper cables, and one is for uplink and one is for downlink. And then it turns out that the HE unit that this is going to connect to doesn't have its own power supply, so we're going to have to send power over to it. So the CS45 is going to supply 12 volts of DC power to the HE unit, and that's what's going to get connected there. The HE unit is going to convert the uplink and the downlink signal from RF to light and send that out of our SC APC fiber optic. Single mode cabling, and we can connect up to 4 of those connectors. The fiber optic cable is going to get connected to the RE, and the RE is going to be in the large building or maybe another campus building, and the RE is going to convert the light back into RF. And the same 3 connectors that we saw before are going to get connected to our remote BDAs or our remote units. So I haven't talked about the remote units yet, but it's very, very similar to the CS45 BDA. It's going to have the same 2.5 watts of downlink output power. It will not have any uplink output power. The uplink power amplifier is disabled, and it's just going to send low-level signals to the RE for uplink, which will be then eventually amplified by the master unit. But these RE unit, the remote units, get powered by the same battery backup unit that the master does. So what you see here is we have one HE unit, and that can supply information up to 4 remote units. So you're going to need 4 REs if you have 4 remotes. Now, what if 4 remotes are not enough? You can daisy chain one HE unit to another HE unit. So Cat5 and 12 volts. We have those internal junctions for the cascading. And then as far as the uplink and the downlink RF, you're going to have to use an external splitter, and you're just going to split that in half to send to the other HE units. And then you'll have 2 HE units, which both can be connected to 4 remote units. So in this case, you have 8 remotes. And I want to emphasize that when I say we have 4 remotes, or in this case, 8 remotes, that's actually 5 zones or 9 zones, because the master unit has its own downlink amplifier. So this can cover 1 building or 1 zone. This can cover 4, this can cover 4, so we can have up to 9 zones, or 9 times the square footage of 1 BDA by itself. We also have another annunciator, which is our DAS annunciator, that if you want to connect this up to an unused RJ45 port, not only can it display the alarms of the master, but it also displays the alarms of every one of the remotes. So this would be a good unit to put in, say, the lobby of every campus building. If you had 8 buildings, when a first responder goes into any one of those 8 buildings, they can see the status of the entire system. So very nice. And it has the same 3,000 feet away from any unused RJ45 port, which could be in the HE unit or the RE unit. Here are some part numbers. This is the part number of the BDA itself or the master unit. Down here is the part number of the BBU and the associated battery. And we also have kits, and kits are really nice. If you order a kit, they come on a single pallet all together. And we have the K1 kits, which will include the BDA, the battery backup unit, and 1 battery for 12 hours. And we have the K2 kits, which is the same thing except for 2 batteries for the 24-hour batteries. And in all cases, the warranty is 3 years. Westell covers everything except the batteries. The batteries are covered by the battery manufacturer's warranty. And as far as the fiber DAS, here are the part numbers for the HE unit and the RE unit. And every individual remote has this part number right here. And same battery backup unit and batteries for the remote. And then the remotes also have their own kits. So you can order the K1 kit for 12 hours or two batteries for 24 hours and get not just the remote, but also the battery backup unit and the batteries. And down here are the part numbers for the annunciators, the standard annunciator, and then the DAS annunciator, if you want to see the status of every component within the system. And that pretty much covers my presentation today. So, Bob, you still with me? And have we gotten any questions?
Yeah, we have a couple. How would you plan / design for the annunciator on a campus with multiple buildings and the fire command being in a separate building that does not actually have a BDA or a remote in it?
Yeah, so when it comes to campus settings and alarms, different jurisdictions have different requirements. Sometimes they allow all the alarms to be summarized for the entire system to be on the one fire alarm control panel. And sometimes they want, if every building had a separate fire alarm control panel, they would want to see sometimes every remote go to those. Now, in this case, you're saying that the fire alarm control panel is in a building that does not have a master. Yeah. So what you would do is, again, depending on what the jurisdiction wants, and I would hope a good summary alarm would be that if any alarm is active for either the master or the remotes, what we could do is hook up your monitor modules to the master unit, and the master unit will indicate if the master or any of the remotes have an alarm. And then you would hook the monitor modules up to the master and then use the SLC loop from the monitor modules to go over to the building. I have to be honest, I'm not an alarm or fire alarm expert, so I'm not quite sure what the limitations of distance is for an SLC loop. But assuming that's doable as far as distance, that's what you would have to do.
Okay, thanks, Tom. Steve has got a couple of questions. First, is there going to be a UHF version of the CS45?
No. So we do have VHF and UHF units, but they're in the CS40 BDA family. The CS45 right now is 700, 800. And for the immediate future, that's what it's going to.
Okay,
yeah, I want to mention though that the fiber DAS system that we just went over with the HE and the RE units, they do work with the CS40 mid and mid-powered VHF and UHF BDAs.
Correct.
Yeah.
Steve's follow-up question is, how sharp is the roll-off on the 12.5 kilohertz filter?
It's in our data sheet. It does mention how far down it is at a certain frequency away. I just don't have that off the top of my head.
Okay. We can. Steve
I do
you
want to mention though that Steve, that we've just recently had a firmware update for the CS45, both the 0.5 watt and then the 2.5, and our filters have been greatly improved over when they initially launched. So if you have seen them when this first came out, the new firmware definitely tightens things up.
Why choose 12-volt DC?
If we had an engineer in here, I guess he could explain it. But overall, it's I guess it's just one of the design goals of this the whole CS45 line was size and weight. And when it comes to BDA when it comes to BDA installations, what is the thing with the most weight? It's the battery. And using only one battery, if we can get away with it, as completely with the 0.5 watt, and sometimes we might need 2 batteries with the if you want 24 hours with the 2.5. It just saves on cost and size and weight.
Agreed. Any other questions? All right, thank you, Tom. One more question just popped up, Tom. Any chance the optical link budget will increase from 5 dBA?
I don't think so. That's pretty much built into the the hardware that was selected.
Yep. All right, thanks again, everybody.